In this video, we're going to finish talking about reflections. We're going to focus on reflections over diagonal lines that have a slope of either 1 or -1. So the two diagonal lines that you're most likely going to have to reflect a figure across are going to be y equals x or y equals -x. And their rules are very similar and very simple. So for y equals x, you just simply swap the x and the y coordinate. And for y equals -x, you swap the x and the y and you change both of their signs. Okay, so basically everything you could do to the points you do. You're going to change both of the signs and swap the two terms. So here we swap, here we change the signs and swap. So now for a quick visual on what a figure might look like if you were to reflect it over one of those lines. Here we have figure TCHS. We have a quadrilateral, and I've gone ahead and graphed the line y equals x. So this is in slope-intercept form. The coefficient of the x term is +1, and it passes through the origin because we can see there's no constant term here. So if we start at the origin, that is our y-intercept, we're going to go up 1, right 1, 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 up 1, right 1. So you do that all the way across, so we have our line of symmetry there. Now if I were to mirror this using my tracing paper, like we've done in a few other examples, this is how that might look. So if I go ahead and line up my tracing paper, again I'm going to take a straight edge, which I have right here. I'm going to place it along that line of symmetry, or the line y equals x, and I'm going to fold the tracing paper over like that, and that's going to give me the mirror image. And I know that sometimes it's easier for students to see when it's vertically, when the line of symmetry is vertically shown. So if that makes it a little easier for you to see than there. So we've taken this quadrilateral and we have reflected it across the line y equals x. Now if you want to talk about applying the rules, or the rule for y equals x, remember from the notes it said that we swap the x and the y coordinate. So let's just look at a couple points and see if that holds true. So for this one, we are going to go -2, -2, 1. So if we just swap those two coordinates, that's going to be 1, -2. So I'm going to go right 1 and down 2, and you can see I get to one of my points. If we try S, we're going 1, 2, 3, 4, -5 and up 1. So if I swap those, I'm going to go 1 and then down 1, 2, 3, 4, 5, and then I get my point S. So whatever the x and the y coordinate are for your pre-image, you simply swap them and you can get the coordinates for the image. So it's a really easy transformation to perform. Another nifty trick that you can use is, if you have the graph, and since our slope is 1 here and it cuts through nicely and gives us nice diagonals to count from, I can actually just count the diagonals from the line of symmetry, similarly to how we did the vertical and horizontal lines. So because we have a slope of 1, if I look at my point H, I'm going to go 1 diagonal and then half to get to the middle where that line is. So I'm going to go the same distance on the other side. So I'm going to go half and then 1, and this is actually where my H prime would be. And I can do that with S as well. So I'm going to count 1 diagonal, 2, 3, and then 1, 2, 3, and there's my other one. And if we keep doing that, I'll have 1, 2, 3, 4, 1, 2, 3, 4. There's my C prime. And then here I'll have 1, 2, 3, 4 and a half, 1, 2, 3, and 4. And that would be T prime. So you can also easily count the diagonals in order to get your image. And even though this is y equals x, it's a very similar process for y equals negative x, which we'll look at in a second after I graph my image here. And there's our final answer. And again, if it's easier for you to see this way, you can see that that is perfectly mirrored across y equals x. All right. Now if we look at our other graph, which is y equals negative x, again, this is in slope-intercept form. We have a slope of negative 1, and there's no constant written there, so it passes through the origin. So from the origin, you're going to go down 1, right 1, 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 all the way down, okay? So that is our line of symmetry. And here is our triangle XYZ. And we can do the exact same process to see what the mirror image would look like. I'm going to fold it across that line of symmetry, and there would be my image. Now here, because it's negative x, not only do you swap the x and the y, but you also negate the signs. So if we pick a test point here, such as z, I'm going 1 in the x, 2 in the y. So I'm going to swap them and change them in order to get negative 2, negative 1. So if I go negative 2, negative 1, there is my z prime, the point that's reflected. So if it's y equals x, you swap the x and the y. If it's y equals negative x, you swap the x and the y, and you change the signs. So if we look at a couple examples on one of the worksheets you guys have. Now on these, the directions just ask you to graph the image, but to help explain this, and what I recommend you guys do since you're learning and you need practice, is I've gone ahead and actually graphed the pre-image, and I have graphed the line of symmetry that you're going to be reflecting over. And this is just to make it easier for you guys to verify that your final answer is in fact mirrored, because as human beings we're sort of genetically programmed to be able to easily identify symmetry. So you have a natural ability to do that. So if you graph the pre-image, then you can take advantage of your human nature. And I just noticed that I forgot to label Q. So that's Q right there. So if we mirror this, I'm going to go ahead and actually just apply the rule here to show you guys how easy that is. Now this is y equals negative x. So according to my rule, I'm going to swap the x and y's and swap all the signs. So not only are both of these now going to be positive, but I'm going to switch them. So t prime is going to be 5, 3. S prime is going to be 0, 3. R prime is going to be 0, 1. And Q prime is going to be positive 2, negative 1. So I've done two things to each of these coordinates. I've swapped the x and the y, and I have changed the signs of both of the terms. So just one more time, I changed both of these to be positive and switched them. This became positive and I switched them. This one became positive and I switched them. This one became negative, this one became positive, and I switched them. So now we're going to go ahead and plot those points. And since we have our pre-image on the graph, we'll be able to see easily if we've mirrored it properly. So we've got t prime, which is going to be 5, 3. We've got s prime, which is going to be 0, 3. R prime is going to be 0, 1. And Q prime is going to be 2, negative 1. So if we graph our image, or I should say just connect the points here, we should have a nicely mirrored figure. I'm just trying to sound fancy. Here we go. So it's looking pretty good. And again, if you want to rotate your paper and look at it vertically, you can see that that is perfectly mirrored. And all it required you to do is to change all the signs and to swap the x and the y's. And you don't have to necessarily graph the line of reflection and the pre-image, but it makes it so much easier if you do, as you guys can see from here. So let's go ahead and do this one. Now this one is just y equals x, so that means that we don't have to change any signs, we just switch them. So if it's y equals x, you just switch them. If it's y equals negative x, you switch them and change the signs. So here I'm going to go ahead and change the coordinates and then graph the picture and see if it's correct. So t prime is going to be -4, -4, because they're both the same. U prime is going to be -2, -5. V prime is going to be 0, -3. Notice again, I'm not changing signs here. I'm just swapping the coordinates. And W prime is going to be -2, -3. So there are our coordinates after we have transformed them. And now I'm going to go ahead and plot the points and verify that I did it correctly. So -4, -4 is going to stay because that is the because that point lies on the line of symmetry, or the line that we're reflecting across. Then we have -2, -5 for U prime, 0, -3 for V prime. It's a little messy. Let's fix that. -2, -3 for W prime. And if I go ahead and draw my picture, go ahead and just connect all the dots. There you go. And again, if we go ahead and rotate it so that the line of symmetry is vertical, we can very easily see that it has been nicely mirrored. All right. So y equals x, swap the x and the y coordinate, plot it. Y equals negative x, swap the coordinates and change the signs. And that's it. All right. Now, what if it's not one of those? All right. So if we scroll down here to number 5, we have the line y equals x plus 2, which most likely you're not going to see, with the exception of possibly on a test at some point. But we still have a slope of 1. So the y-intercept is positive 2, and we still have a slope of 1. So that just means that we're going to start at positive 2 on the y-axis, and from there we're going to go up 1, right 1, up 1, right 1, up 1, right 1. And because we still have a slope of 1, we can easily count the diagonals, or we can change the coordinates like we have right here. So I have the image already graphed. Excuse me, the pre-image. Before we've done anything, these 3 coordinates, I've got the pre-image graphed and I have the line of symmetry graphed. So I'm going to go ahead and do the same thing. Oh, actually, you know what? We can't use the rule here because it's not y equals x. So we're going to have to count the diagonals. Almost made a mistake. Almost made a mistake, but I caught myself. So here, I'm going to zoom in on this. I'm going to zoom in on this, and here we our only option is to count the diagonals. So I went half to get from the line of symmetry to G. So I'm going to go half the other way to mirror it. So that's going to be G prime. R is exactly 2 diagonals above it. So we're going to go 2 diagonals below it for R prime. And C is 1, 2 away as well. So we're going to go 1, 2 here. And we're going to plot C prime. And I'm going to connect all of my points. And again, if I rotate my paper, so that that line of symmetry is vertical, I can easily see that we have mirrored the image. All right. Now on the back side here, we're almost done. On the back side here, I've gone ahead and graphed a couple of these problems. So basically a concept that we want you guys to understand is that if you reflect any figure across 2 lines that are parallel, what's going to happen is the first image is just going to be a reflection across whatever line, of course. And I think I made a mistake on that one. I did. So we're going to ignore that one. That never happened. Let's go to this one. So And just so we can see the mistake that I made right here, you know what, let's go ahead and just fix it. We have erasable pen. Let's not leave this problem undone. So I went one left here. I'm going to go one right. I went 1, 2, 1, 2, and then 1, 2, 3, 1, 2, 3. So what happened there is I accidentally counted incorrectly. But that's okay, because I can quickly fix this, because that's how easy it is to reflect over a line, guys. Even if you totally mess it up, it takes maybe a minute to fix. So let's just go ahead and fix it, because you know what? It's okay to make mistakes, as long as you learn from them. Here we go. And I'm going to go ahead and reflect this. So the directions give us coordinates, and they ask us to reflect it over 2 lines. And once you graph the 2 lines, you can clearly see that they are parallel. Now, because I'm performing 2 reflections, I'm reflecting across 2 different lines here. Those are 2 different transformations, and therefore my notation has to represent that. So from the triangle that's in black here, that is my pre-image. So I reflected it 1 time, and I got A prime, B prime, and C prime. And then I reflected it again, and I got A double prime, B double prime, and C double prime. And I'm just verifying. Looks like we're good. Now I did change this problem because it didn't look like it was going to work out the way it was before. And I created the worksheet so by myself with nobody else's help. And it was supposed to be x equals -1 initially. So I went ahead and changed that. So we have the vertical line here, which is x equals -1, which means it's a vertical line that passes through -1 on the x-axis. And then the other line that they want us to reflect it across is x equals 3. So that means it's a vertical line that passes through 3 on the x-axis. And that is what we did in the last video, is just practice reflecting over vertical and horizontal lines. So if we look at our images here, the concept that we want you guys to understand is that if you reflect an image over 2 parallel lines, as we've done here with triangle ABC, what ends up happening is that this turns into a translation. And to demonstrate that, we can use a piece of tracing paper real quick. I'm just going to trace over this guy. Okay. So if I look here, if I look at my pre-image, I can actually get the final triangle, A double prime, B double prime, C double prime, if I just slide it across the paper. And now this one, because the lines are reflected across are vertical, we're actually just going to the right. But even if the lines were diagonal, even if I ended up, having to go down and to the right or up and to the left, as long as the orientation of that shape is not changing from the pre-image to the final image, then we can still interpret it as just having been a translation. And so we're going to write that rule down below when we're done. So let's look at this next one here. And I've already graphed this because you guys need to know how to graph these lines. That's a skill that you learned long ago. And we've continued to review it. You guys already know how to reflect figures, even if they're over a diagonal line. It's very straightforward. So here I have 2 lines. I have y equals x minus 3. So that means I'm starting at -3 on the y-axis, and I've got a slope of 1. So I go up 1, right 1, up 1, right 1, up 1, right 1. And for my other line, I have y equals +4. So I'm going to start at +4, and I'm going to go up 1, right 1, up 1, right 1, up 1, right 1 from there. And here It looks like I was supposed to for this one. This is my original image, -6, 0. So these two lines look like they were swapped right there. All right, because my pre-image is here. So when I reflect it, I'm going to be reflecting it over x plus 4 first, and then I'm going to be reflecting it over x minus 3. That's just how it's going to go if you follow the reflection. So let's just pretend that those two lines are swapped. All right. Again, I made this worksheet on my own without anybody's help, so it's not my fault. But anyway, so we have our triangle MSA. And if I reflect it, I'm going to rotate this so you guys can see this more easily. If I reflect this triangle across the first line, just pretend this isn't even there. Pretend that's not even there. If I reflect this across the first line, we can see that it's been mirrored correctly. And then if I pretend that this one isn't here, and I mirror it again over the other line, I can see that those two have been mirrored properly. Now, if you look at the orientation of the pre-image to the final image, M double prime, S double prime, A double prime, we have the same orientation. So that means that instead of reflecting it twice over these two lines, what I could have done is I could have just slid it a certain number of units and also gotten the same thing. So if you are translating, if you are reflecting an image over two parallel lines, the final image can also be achieved if you were to just perform a translation. Now, down at the bottom here, they want us to write the rule for the translation that's being performed. So I'm going to sneak back up here to number 7. And if I count from B to B double prime, I'll get my translation. So I'm going to count 1, 2, 3, 4, 5, 6, 7, and 8. I'm going 8 units to the right, and I'm not going up or down. So if we go down here to number 11, all right, so this is going to be the one that we do for number 7, because it came first. And then number 9 will be for number 13 here. So if I want to write the rule here, for every xy, I'm going to add 8 units, but y is going to stay the same. So this is the translation that will also result in my final image that I have here. If I just took this triangle ABC and shifted it right 8 units, I would end up with this image, which happens to be the same thing as if I reflected it over the line x equals -1 and the line x equals 3. All right, and that happens because the two lines of reflection are parallel. If they are not parallel, then that won't occur. So let's do the same thing here. So again, I'm just going to count from A to A double prime. So if I count here, I'm going to go right 1, 2, 3, 4, 5, 6, 7, it looks like. And I'm going to go down 1, 2, 3, 4, 5, 6, 7. So I went to the right 7 units and I went down 7 units. So that means that I'm going 7 units to the right, which is x plus 7, and I also went down 7 units, which will be y minus 7. Sorry, that was out of focus. So looking back up at these, and I know this is, it seems a little complicated, but it's not. Once you have the actual lines graphed and the initial image, the pre-image graphed, you're simply performing 2 reflections. So again, if you could just cover this up, that's very easy to reflect. And then if you covered this one up, that's also very easy to reflect. And because we're reflecting over 2 parallel lines, we can actually also achieve the same transformation as if we just slid it across to our image. Same thing down here. If we pretend this one's not here, we can reflect those 2, counting the diagonals. And if this one wasn't here, we could also reflect those 2, counting the diagonals. But because we reflected over 2 parallel lines, we could achieve the same transformation if we just took this triangle and slid it to the left and then down 7 units, right? So in terms of reflecting over diagonal lines, most of the time you're just going to have to reflect over y equals x and y equals negative x. So if you have to do one of those, here's the rules, and they're very easy to apply. If you have to reflect over any other diagonal line, such as the one we did on number 5, then all you have to do is just count the diagonals. And even if it is, especially if the slope is 1, it should fall nicely. It's either going to fall on a diagonal that intersects at a grid line, or it'll be directly in half so that you can easily count them. And that's it. That's how you reflect over diagonal lines.